Hello friends, let us solve another problem based on the bearing capacity of a pile in sands. So I have considered the previous data as it is, but what we have included here, we have included the critical depth. So if critical depth is included, then we will see how to find out the capacity. Okay, now first let me draw the pile. So what about the critical depth? 4 meter. What does it mean? Up to 4 meter, your vertical stress will increase. After that, you have to keep it as a constant. So it is 4 meter and 2 meter. Now, up to 4 meter, what about the value? It will increase, increase and increase. And at this point, what is the value? If I convert into centimeter, 400 into 2, that implies the value will be 800 gram, isn't it? Now, after this point, we have to assume it as a constant till the remaining depth. So this is what about the variation of vertical stress if there is a critical length is given. In the previous problem, critical length is not given. That's why we have considered vertical stress is uniformly varying. But here, as a critical depth is given up to the 4 meter only, your vertical stress will vary. After that, it will be remains constant. Now, what about the sigma V dash? That is nothing but a vertical stress at the tip of the pile. At the tip of the pile, what is the value we are assuming it as? 800 gram per centimeter square. Now, after that, what we have to find? Let me tell you what about the frictional value. That will be nothing but a AS into K into sigma average effective stress into tan delta. So take out the parameters that are independent of the stress. That will be nothing but a L tan delta common. K value I'll take it a common. Diameter is also constant. That's why I'll say pi into D also common. What is the remaining term? Length. Length into what is the value? Average value. So what is meant by L into average? This is nothing but a total magnitude, total stress. So we have to see what is the total vertical stress. So you know what I will write down here? Tan delta into K into pi into D into. Now, tell me, in between this region, your stress is varying. So I'll consider this as one part and I will consider this as another part. Suppose if I'm talking about this part, what about the average value? 800 plus 0 by 2. So over a length of 4. That's why length I'll take it as a 4 into 800 plus 0 by 2. This is 800. Plus whatever the remaining 2 meter. Your value is constant. If your value is constant, what about the average? 800 only. Plus 2 into 800. Now see how the problem has become. So instead of finding the average value and then multiplying with the total length, we will combine these two and we will write in effective manner. So up to 4 meter, we will write down the what is the average stress. What is the average stress? 800 plus 0 by 2 into 4. And the remaining two values, the average is constant. So that's why if your vertical stress is varying, it will be better if you write average stress into length in combined manner. Now the problem is easy. Now directly write down the ultimate capacity equation. What is ultimate capacity equation? AB and bearing area, that is pi by 4 into diameter 45 square into what about the average stress? There it is 1 into how much it will be? At the tip it will be 800 into what is the NQ value? 18 plus what are the constants? Pi is constant, D is constant and K is constant 1.2. Tan delta, what is the delta value? 20. Tan 20 is constant. What are the remaining terms? L into average. The L into average, what I'll write? 4 into what is the average value you are getting? 400 plus 2 into what is the remaining value? 800. If you solve this, you will get your ultimate capacity as around 23,088 kgs. So if we represent this in terms of the tons, we will get ultimate bearing capacity as 23 tons. So what is the difference between this problem and the previous problem? In the previous problem, there is no critical length. In the present problem, there is some critical length. So if there is a critical length, up to that only we have to consider the variation of the vertical stress. After that, we have to consider remain it as a constant till the end of the pipe. So if there is any critical depth or wherever there is a change in the vertical stress, divide that into number of parts and then write down the average stress value. That will be easier for you. Okay. In the next video, we will solve the same model, but we'll consider by what we'll consider the water table and then we'll solve the problem. Okay. Thank you.